All right, I am going to attempt to simplify this log. This one is very, very tricky. So really what I'm going to do is I'm going to probably distribute this -1 to both. Because really, otherwise, if you think about it, it might be a little bit difficult to, if you use the power, you're going to have to take the square root of a binomial. Very difficult to do. Anyways, 4 log base 3x minus 1/2 log 3 of x plus 5 to the log, sorry, incorrect, minus, right, if -1/2 times 5 turns into -5/2 log base 3x. All right, now I have this all in a constant row here. I'm feeling pretty good. So I am going to now use the product rule. So log base 3x to the power 4. Now my base is too big there. 3, wrong marker. Log base 3x to the power of 4. All right, just give me some pause here. So I have 3 terms of logs, and they all have the same base. Some logs are positive, some logs are negative. So maybe the positive term is x to the power 4. And I'm going to choose to put, nope, incorrect. I'm really struggling with this one right now. You know what? I'm going to put to the power first. I'm going to use the power law. So log base 3x to the power 4 minus log base 3x to the power of 1/2 minus log base 3x to the power of 5/2. I hope that helps. So right now, I am struggling with this question, and I think it's really good that you're seeing somebody struggle with a question and the strategies that they use. Me, I like to talk things out. So right now, I think that I have logs with the common base and their differences. So right now, I'm going to use the quotient and product rule to sort of put it all together. And to put it simply, and since I'm trying to break this up, some of these arguments will go in the numerator, some will go in the denominator. And so really, this is log base 3, x to the power of 4. Now, it's in the numerator because it's positive, minus x to the power of 1/2 times x to the power of 5/2. Now, I'm running out of room here. Now, this is a beast of a question, is it not? So I'm going to try to simplify the denominator here. So that's the log base 3 of x to the power of 4 divided by x to the power of 1/2 times x to the power of 5/2. Well, we would add those exponents. So really, this would be x to the power of 3. Really and truly, this simplifies into log base 3, x to the power 4 divided by x to the power 3 is just simply x. Wow, that was a tough question. No lie, that was a tough question. But hey, that's why we're taking this course, to challenge ourselves. Oh my God, the great news never ends, eh? Like, look at this one. This one's equally a beast. All right. First, I'm going to put my restrictions. So x squared minus 9 has to be greater than 0, and x squared minus x minus 6 has to be greater than 0. And you need to figure out those values where this is possible, right? I'm going to worry on the logarithms. So here, I'm going to write this as log 2. I'm going to use the quotient rule of x squared minus 9 divided by x squared minus x minus 6. Now, I'm going to choose to do that. Why? It's just a gut instinct that I have. And what I can see here is that this is log base 2 of x minus 3 times x plus 3 divided by, if I factor the bottom, that's x minus 3, x plus 2. And in our argument, what we see is that there exist both common factors of x minus 3, so I can cancel this out. So really, this just simplifies to log 2 of x plus 3 divided by x plus 2. And let's take care of some of those restrictions. X squared minus 9 is greater than 0 when x is less than negative 3 or x is greater than 3. Now, x squared minus x minus 6 is greater than 0. Well, I'm just going to make a quick sketch of this graph to help me out. And I notice, you could do it with inequalities too, and I notice that I have 2 zeros for this, and you could factor it and figure it out. I have 2 zeros, one at negative 2 and one at negative 3. So I get the restrictions that x Now, the restrictions are really tough. So if you're going to drop the whole argument about restrictions, that's acceptable for now, but in the next little while, you need to get past this. But anyways, what are the greater restrictions? These are my greater restrictions, right? So x has to be, for sure, less than negative 3 or greater than 3. We simply ignore this one here, because if x is negative 2.5, the top restriction is not obeyed. All right. Wow, tough question. Hopefully this ends soon. I'm just kidding. I'm having a great time. If log 2, 5, or if x is equal to log base 2, 5, and y is equal to log base 2, 3, we're going to write the following x and y. Fair enough. So log 2 of 625. What I can do, though, is I can try to write 625. What does that have to do with numbers of 2 and 3? Well, I know that 625, I could write this as 5 to the power of, I know that 25 times 25 is 625. So really, this is 5 squared times 5 squared. In other words, 5 to the power of 4 is 625. So what we know, if you notice, right here, log base 2, 5 to the power of 4, we're getting very close to where we need to be. That value is x. But now I'm going to apply the product rule, which says 4 times log 2 base 2, 5. Log base 2, 5 is x. So this is equal to 4x. Well, fair enough. How about, let's move on to the next one. Log base 2 of 15. Well, if I'm trying to use these two identities, I can split this up into log base 2. How can I split up 15? Oh, I know. 15 is just 3 times 5. And since these two the arguments are being multiplied, I could write this as log base 2, 3 times or plus the log base 2 of 5. And we know that x is log base 2 of 5 is equal to x, and log base 2, 3 is equal to y. So this is y plus x or x plus y. Fair enough. I like this. This is fun. All right. This one can be a little bit tricky. I'm not seeing my way out of this. If I split up 300 into its factors, let me just start off with a factor tree here. And I'm going to try to create multiples of 3 and 5. So this is really 100, and this is really 3. And 100 is 4 times 5 squared, right? And this is 3. So really, this is log 2 times 4 times 5 squared times 3. We could split it up like this. And I'm going to use my product rule to say that this is equal to log base 2 of 4 plus the log of base 2 5 squared plus, I don't like the way that looks, base 2 5 squared plus the log base 2 of 3. Well, log base 2 4 is simply better known as 2. 2 to the power of 2 is 4. And now I'm going to use the product rule. The log base 2 of 5 can be written as 2 times log base 2 of 5 plus log base 2 3. So I'm just going to look back at my definitions. This is 2 plus 2 times x plus, right, this value is x, plus y. All right. That was a long, long lesson. I hope you enjoyed it. Logarithms can be tough, but really we're just messing around